540 feet down at 30 and at 15. Contact light. Okay, engine stop. ATA at a descent. Mode control both auto, descent engine command override off. Engine arm off. 413 is in. We copy you down, Eagle. Listen, Tranquility Base here. The Eagle has landed. Roger, Tranquility. We copy you on the ground. You got a bunch of guys about to turn blue. We're breathing again. Thanks a lot. Thank you. You're looking good here. Okay, we're going to be busy for a minute. Master arm on. Take care of the seat. I'll get the stuff prepared. Okay, it looks like we're mending the oxidizer now. Roger, Eagle, and you are safe for T1. Over. Eagle, you are safe for T1. Roger. And we Sam safe for T1. Roger, and we see you venting the ox. Okay, Neil, we can see you coming down the ladder now. That's one small step for man. One giant leap for mankind.
Please welcome Andrei Iancu, Undersecretary of Commerce for Intellectual Property and Director of the United States Patent and Trademark Office.
It suddenly struck me that that tiny pea, pretty and blue, was the Earth. I put up my thumb and shut one eye, and my thumb blotted out the planet Earth. I didn't feel like a giant. I felt very, very small. That was Neil Armstrong's description of his experience on the moon 50 years ago this past Saturday. Landing on the moon on July 20th, 1969 was the ultimate triumph of human ingenuity and innovation. For when we humans harness that most unique of human qualities, the power to reason, to work together, to invent, we are capable of the most remarkable things. These very, very small creatures on this tiny pea, pretty and blue, are capable of giant leaps indeed. This is in fact what inventors do every day. And this is what we celebrate in particular here today. Good afternoon, everybody, and welcome to the United States Patent and Trademark Office and to this incredibly special event. Through the doors of the PTO comes our future. And through our examiner's hands will pass, among many other things, machines that transport humans to other planets. It took less than 65 years from the Wright brothers' patent to Neil Armstrong's first step on the moon. And the fact is that the pace of innovation just keeps accelerating. At the USPTO, our focus on promoting innovation is what drives our keen interest in space technology. We humans are most creative when we push ourselves to the furthest limits of what we can think of as possible. We find solutions to problems we didn't even know existed. And we make unexpected discoveries that may have uses outside our immediate field of endeavor. Just as the Apollo program ushered in a bold new era of technological advancement, the likes of which the world had never before seen. As just one example, the Apollo program greatly accelerated the development and commercialization of integrated circuits, which are in nearly every single computing device you interact with today on a daily basis. Indeed, more than 1,000 NASA technologies have been spun off into commercial products and services, and we can expect many more from continued space development. The economic benefits of space innovation, backed by a strong intellectual property system, are astounding. This is what we will explore today during our various programs, speeches, and panels. You will hear from the United States Secretary of Commerce, who will address the administration's commercial space policy. And you will hear from representatives of companies and trade groups in the actual space industry itself. You will hear from a National Inventors Hall of Fame inductee. And you'll hear from two of the true rock stars of space, real-life astronauts, including, by the way, the first woman who walked in space and also an inventor. But first, a real treat. Our esteemed keynote speaker, NASA Administrator Jim Bridenstine. Mr. Bridenstine began his career in federal service as a U.S. Navy pilot, flying combat missions in Iraq and Afghanistan in the E-2C Hawkeye. He later moved to the F-18 Hornet and flew at the Naval Strike and Air Warfare Center, the parent command to Top Gun. Mr. Bridenstine served as executive director of the Tulsa Air and Space Museum and Planetarium, while continuing to serve in the U.S. Navy Reserve. In 2012, he was elected to the U.S. House of Representatives in Oklahoma's 1st District and served on the Armed Services Committee and the Science, Space, and Technology Committee. He was confirmed as NASA's 13th administrator on April 23, 2018. And we are extremely honored to have him here today as we celebrate the 50th anniversary of the Apollo moon landing. Please join me in welcoming Mr. Jim Bridenstine. Thank you so much for coming.
Thank you. Well, it's great to be here. Thank you all for taking some time to understand a little bit about space and some of the technologies and spin-offs, and of course, how we go about patenting these technologies so we can, in fact, share these technologies with the entire world, and entrepreneurs and businesses can in fact improve the human condition, which is really what NASA is all about. And sometimes people are not aware of that. And what I'd like to do is share a little bit about what NASA is and how we do this. But here we are, 50 years after Apollo. We had just a stunning weekend. I don't know if anybody went out to the National Mall, but I understand. Yeah. I want to be clear, that was largely done by the Smithsonian Air and Space Museum. They did a wonderful job, and of course NASA is a big beneficiary. But as a member of Congress, you mentioned, certainly I've seen all kinds of large groups organized at the National Mall. Never a group that was united. Always somebody protesting something, lots of people yelling about something, and here we had a moment in time, 500,000 people on the National Mall of all different backgrounds, all different parties, all different everything coming together to celebrate this very unifying moment, not just in American history, but in fact in world history. And we have to think about where we came from. Remember, the 1960s was a time of turmoil in our country. We had the Vietnam War at its peak, and of course there were protests about the Vietnam War. We had, in fact, civil rights abuses and civil rights protests. There was a lot of turmoil in our country. And a lot of folks would have said that our country was going to come apart because of how cantankerous it was. And yet, this one moment, July 20th, 1969, the whole world watched as Neil Armstrong and Buzz Aldrin walked on the moon. And so it wasn't just unifying for our country, it was in fact unifying for the world. Remember, it was a contest of great powers. It was the United States of America against the Soviet Union. And of course, we were trying to demonstrate our technological prowess because we were really trying to demonstrate that our political system and our economic system was superior to that of the former Soviet Union. And of course, when Neil Armstrong and Buzz Aldrin walked on the moon, we were able to say, look at what we were able to achieve. And of course, we did that mission not just once, we did that mission 6 times with 12 people walking on the surface of the moon. And when Apollo ended, the Soviet Union reached out to the United States and said, why don't we partner together in space exploration? And of course, the United States looked back and said, that would be a great idea. Let's share in this burden. And then we put together the Apollo-Soyuz program that launched in 1975, where we had American astronauts and Russian cosmonauts living and working together in space. Eventually, that led to the Shuttle Mir program. Again, another capability of diplomatic achievement that NASA brings to the table with the Shuttle Mir program. And today, with the International Space Station. We've had Russian cosmonauts and American astronauts living and working together in space for almost 20 years. So what ended up, where we started, was this very hotly contested space race for political and economic ideology, and where we ended up was a partnership that even continues today, and that's a very positive development. But I want to be clear about ultimately the technologies, and people say, well, why did we go to the moon? And then they say, why do we go to the moon today? And why are we going to Mars? And they ask these questions, and I'll share with you a couple of reasons why we went to the moon in the 1960s, and I will tell you at the time nobody probably foresaw what would come of this program, this capability called NASA. So think about some of the technologies that we have available to us today. I know people in the room, many people get their television, maybe DirecTV or Dish Network. Maybe you get your radio, XM radio. Maybe you get your broadband, your internet from space. All of these communications, over-the-horizon communication technologies and capabilities were born from this little agency called NASA, and it even started even before the Apollo program. 1958, when you think about it, a lot of these technologies were being initiated in a time of the NACA, which was the predecessor to NASA, which got created in 1958. But all of these technologies and capabilities were born from this little agency. And now, of course, they've been commercialized. They've been privatized. And when we think about space-based communications as an economic development capability, it is now literally hundreds of billions of dollars worth of economic impact per year. Hundreds of billions of dollars of economic impact per year. A lot of it is exports for the United States of America, which is critically important to our country. So we think about just the communications side of the capabilities that came from the Apollo era, but it's not just about communications. It's how we navigate. Again, this little agency called NASA eventually created a technology for GPS that eventually got transferred to the Department of Defense. And of course, that technology is probably how a lot of people in this room got here today for this event. It has transformed the human condition. And that GPS technology is not just about navigation. It's also about a timing signal that has again transformed the human condition. We think about banking. Every banking transaction in the United States of America requires a timing signal from GPS. And we think about the regulation of flows of electricity on the power grid. Again, it requires a timing signal from GPS. And when we think about the regulation of flows of data on terrestrial wireless networks with your cell phone, again, it requires a timing signal from GPS. These technologies and capabilities have elevated the human condition. And when we think about what NASA's budget is, we're talking about less than 0.5% of the federal budget. So how is it that NASA can do these activities that ultimately have these transformative kind of capabilities? And the answer is really simple. Because we commercialize, we privatize, we let entrepreneurs take advantage of these capabilities and move them forward in ways that elevate the human condition that we could never do on our own, and in fact, we could never do if the government controlled all of this technology itself. That's where the private sector matters, and that's where all of this technology matters. But it's not just communication and navigation and the timing signal. We think about how we produce food in this country. Right now, NASA is working with the University of California Cooperative Extension to increase crop yields, while at the same time reducing water usage and preserving nitrates in the soil so we can feed more of the world than ever before. And these technologies and capabilities right now, they're being tested by this little agency called NASA, and we're using satellites that are looking at the Earth and every part of the electromagnetic spectrum to see if these capabilities will ultimately provide fruits in the future, I guess literally in this case, fruits. And what we're finding is yes, it does. And so the question then becomes, how do we make sure that this technology is commercialized? So when we want to go beyond a small farm in Central California and we want to expand our what we call evapotranspiration numbers for the entire country so we can create very specific irrigation plans to increase crop yields, reduce water usage, preserve the nitrates in the soil, which ultimately prevents the nitrates from ending up in our drinking water, which costs a lot of money to clean out. How do we do all of that? Well, NASA is doing all of this activity. And by the way, it's not just the way we produce food. It's how we understand the snowpack in the Sierra Nevada mountains. And how do we take the technologies that we're developing to understand, why do we care about the snowpack? Because there is a water equivalent that is associated with that snowpack. And NASA technology is able to understand the color of the snow, split that white snow into all parts of the rainbow, and then figure out how much of the light is being reflected and how much is being absorbed. And from that information, make a very quick and accurate assessment as to how soon that water is going to melt, how soon that snow is going to melt. And then we can also predict now where it's going to end up. Why does that matter? Because reservoirs need water during fire season. They need water when it's really hot and people are going to be watering their lawns. But we also have to make sure that we're preserving endangered species. And so NASA can help figure out where the water is going to be when, and water managers can more effectively manage the water to protect those endangered species while protecting the water use for drinking and irrigation and, of course, protecting it and make sure it's available for the farmers as well. And, of course, hydropower, another capability of the water. So NASA is doing these things to improve the human condition all the time, but we did not put these satellites in space that are looking at the Earth and every part of the electromagnetic spectrum. We did not put these satellites in space for that purpose. We put it in space so we can understand how our Earth is changing. And now we're finding out that there's capabilities here that we can leverage for the future. And of course, NASA is not going to be creating irrigation plans for every farmer across the United States of America, nor are we going to be doing it for every farmer across the world. But here's what we know. Water isn't getting created in any bigger quantities than it ever has been, yet we got to feed more of the world than ever before. So what NASA can do is really figure out what the technology and the capabilities are, and then license it. Make sure that it's available to private companies so that farmers can get that access to that information, but instead of the government doing it all, it can be privatized. So the way we communicate, the way we navigate, the way we produce food in this country is changing. The way we produce energy. We have a number of missions, again, that are looking at the Earth from every part of the electromagnetic spectrum, and we're making discoveries that when certain companies drill for oil, we see methane leaks. Or when we transport coal, we see methane leaks or different greenhouse gases that are being emitted in either the development or the transportation of fossil fuels. Well, NASA can see that from space right now, and we can very quickly share that with private companies. And why would we do that? Well, we do that because those private companies want the information because they don't want to get fined by the EPA. It's actually a good thing. So you've got energy companies and environmental groups that are in agreement that we want to make sure we have this information available to the public. But again, NASA's goal here is not necessarily to do that for these private energy companies. There could come a day when that itself would be a capability that could be licensed, and private companies could take on that role so that NASA isn't doing that again. We don't want to be the everything to everybody all the time, but what we can do is we can take what we invent, what we utilize, what we learn, and we can share it with the world. The way we communicate, the way we navigate, the way we produce food, the way we produce energy cleanly, safely. We talk about weather prediction. A lot of people don't realize 80% of the data, you get up in the morning, you turn on Channel 4 News or whatever it is you watch, and you see the green blob on the screen. And you know that green blob is going to be over your part of Washington, D.C. at 3 o'clock in the afternoon, so you're going to take an umbrella, maybe you're going to take a raincoat. 80% of the data that goes into that numerical weather model is data from space. Now, these are satellites that are operated by the Department of Commerce through NOAA, but at the same time, these are satellites that are built by NASA, and these technologies were born from NASA. And of course, some of these technologies, when you talk about GPS radio occultation, which is going to help us improve our modeling, give us more data for our data assimilation systems and numerical weather models For weather prediction, a lot of these companies now are being privatized with GPS radio occultation capabilities from space to improve weather forecasting. So the way we predict weather, the way we understand how our climate is changing, and it is changing, these are technologies and capabilities developed by NASA, and all of this data is shared with the world for free. And of course, a lot of people are familiar with national security and defense, disaster relief. A lot of technologies get transferred to the Department of Defense, especially as it relates to communication architectures. And in fact, a lot of it gets commercialized, and then the Department of Defense leases the architectures for space-based communications. So we think about all of these things space-related that have elevated the human condition. It is immeasurable, friends. The way these technologies and capabilities have elevated the human condition is something that nobody could have ever predicted in 1958 when President Eisenhower created NASA. You wouldn't have known how all of us would benefit. It's also important to note that because we benefit from space, and in fact, because we are now dependent on space, there are people around the globe who are not friendly to the United States who have declared space to be the American Achilles heel. And so it absolutely must be protected as well. So when we think about the protection of space, what are we talking about here? We talk about the president who has talked about creating a space force. Just so you're aware, in the House of Representatives, I was in the House the first time the Space Force was voted on. We called it the Space Corps. It was really it would be under the Secretary of the Air Force, but it was a Space Corps that would be able to compete for resources at the same level of the other departments and services. And know this, in the House of Representatives, it got 344 votes. Strong bipartisan support. And that was on the full floor of the House. When it was in committee, the Strategic Forces Subcommittee, it got strong bipartisan support, almost unanimous on the committee. And then the Full Armed Services Committee, again, almost unanimous. And then it got 344 votes on the floor of the House. We don't find votes like that too often. That shows you that there is strong commitment to making sure that space is secure because we are so dependent on it. Again, the enemies of the United States, I should say the competitors of the United States that we hope don't become enemies, call space the American Achilles heel. What we have to do as a nation is make sure that they understand that they will gain no advantage over the United States of America by wrecking space. And by the way, it becomes an existential threat when you think about the power grid and you think about banking. Look, if you lose banking in this country, there's no milk in the grocery store within 3 days. That is an existential threat to our country. It needs to be mitigated. And of course, I think we ought to have policies that make sure that space is protected. And so that's what we talk about when we talk about a space force. Now, the next step is this. We're going back to the moon with an entirely different architecture than what we did in the 1960s. This time when we go to the moon, we're going to stay. What does that mean? We think about a lot of the technologies that have been advanced, the miniaturization of electronics, the ability to store power in smaller batteries so we can get more energy density, the ability to reuse rockets, the ability to, in fact, reuse all kinds of architectures. We're putting a permanent command module in orbit around the moon called the Gateway. And we're going to have reusable landers that go back and forth to the Gateway. Think of it as a small space station in orbit around the moon with landers going back and forth, all done commercially. NASA wants to be a customer. If you look at what we're doing in low Earth orbit right now, we have partnered with commercial companies to resupply the International Space Station. NASA is no longer purchasing, owning, and operating the hardware to go to the International Space Station. We're buying it as a service. Who can take it to the International Space Station at what price? And that's how we're getting our cargo there. Within a year, we will be launching crew to the International Space Station, American astronauts on American rockets. But these rockets are not purchased, owned, and operated by NASA. These are going to be rockets that the private sector has developed for their own purposes, and NASA has been a partner in that development. But at the end of the day, we want to buy a service. We want to be one customer of many customers in a robust commercial marketplace in low Earth orbit. And eventually we want to have commercial habitats in low Earth orbit. In other words, commercial space stations. Commercialize low Earth orbit, why? Because then we can use the American taxpayer resources to do things that only government can do. In other words, go to the moon and commercialize there. And of course, the more we commercialize, the more government can remove itself from the problem and go to the next thing, which is Mars. And I will tell you, the president is very keen on Mars. You probably saw his 4th of July speech. He wants to put an American flag on Mars, and so do I. And that's what we're working towards. We think about Mars, a big challenge. Earth and Mars, we're only on the same side of the sun once every 26 months. That means when we go, we got to be willing to stay for long periods of time. How do we do that? We prove it out at the moon. The moon is the proving ground. Mars is the destination. Here's what we know about the moon because of discoveries made by NASA since 2008 and 2009, so within the last 10 years. The moon has hundreds of millions of tons of water ice on its south pole. Water ice represents air to breathe, it represents water to drink, and of course it's hydrogen and oxygen is the same fuel that powered the space shuttles. In other words, rocket fuel on the moon in hundreds of millions of tons. We need to figure out how to utilize that. How do we commercialize it? How do we enable commercial companies to utilize it? And then go on to Mars. Now I'm going to anchor for a second on Mars, and then I'll open it up to a few questions. Why does Mars matter? Within the last year, we have found complex organic compounds on the surface of Mars. The building blocks for life exist on Mars. They don't exist on the moon at all, 0, but they're all over Mars. Methane cycles on Mars are commensurate with the seasons of Mars. That doesn't guarantee that there's life there, but the probability just went up. And by the way, we have found liquid water 12 kilometers under the surface of Mars within the last year. What does that mean? Well, what do we know about water on Earth? Wherever water is on Earth, there's life. I'm not saying there's life on Mars. We haven't found it yet. But the probability keeps going up. How do we find it? We got to go. We need to go to Mars to find life on a world that's not our own. And in my view, to do that, we're going to have to take advantage of commercial companies. If you look at the President's Space Policy Directive 1, it says to go to the moon sustainably. In other words, stay at the moon. We don't want it to end the way Apollo ended. Go to the moon sustainably. Go with commercial partners. That means a lot of our private companies are going to own the IP, not necessarily NASA. Go with private companies, commercial partners. Why? Because we believe that they will have customers who are not us, and then our costs go down. So we want to be one customer of many customers, and we want to have numerous providers that are competing on cost and innovation, driving down cost and increasing access. Private industry is how that happens. I mean, if you look at what's happening right now with commercial crew and commercial resupply to the International Space Station, it's going to be transformational from a cost perspective. Why? Because private industry is innovating. These reusable rockets that you've seen resupply the ISS and of course come back to Earth. These reusable rockets, so this is NASA set the parameters. Who can get us there the most cost effectively? We're not going to tell you how to design your rocket, but who can get us there most cost effectively? And people invested. And the way they invest in? Reusable rockets. Because if you can reuse the rocket, the cost comes down for every additional flight. It's not, imagine flying here from wherever you might have flown here from, and once you get here, you have to throw away the 737 that you flew in. The cost would be prohibitive. Well, we don't want prohibitive costs. We want to drive down costs. It means we need private industry to innovate. And we need to set the conditions by which private industry can innovate. That means a lot of the intellectual property is going to be owned by private industry. There are certain capabilities that the government absolutely must have for strategic purposes, and of course we will preserve the intellectual property on those technologies, but there are other technologies where we want innovation and private industry to move forward. But the goal here, Space Policy Directive 1, go to the moon, go sustainably, go with commercial partners, go with international partners, utilize the resources of the moon, learn how to live and work on another world, and then finally take those capabilities and technologies and go on to Mars. And that's when we're going to find life on another world. I think I should say this. I'm the NASA administrator. I have to be careful. I think the probability of finding life on Mars is going up. And I think it would be transferred. And when I say life, I'm not talking about bunny rabbits. I'm talking about microbial life. That's what I'm talking about. So anyway, in order to achieve this, we're going to need to unleash American industry. That means intellectual property, patents are critical. And with that, I'll open it up to a few questions. Thank you guys so much for having me. It's great to be here.
You have a mic?
I think Chris is going to ask.
Okay.
So, we have a mic on the fly here.
All right.
But we've got a couple questions that came in from the audience that we've put together. So NASA has been a very prolific patent filer. We routinely see NASA IP underline many, many common everyday technologies in our lives, many of which you mentioned. Where should Americans expect to see the most important advances and gains arising from the next generation of NASA's IP portfolio?
So yeah, that's a great question. And if I knew that, I would share it with you. So again, we have to think about where we were in 1958 when we started, Mercury and then Gemini and then Apollo. And what was the vision back then? I hear a lot, and just so everybody is clear, as the NASA administrator, I hear a lot about Tang and Velcro. To be clear, neither of those are NASA inventions. But it's also true that NASA benefited from them, and we've utilized them. But NASA has done so much more than Tang and Velcro. And if you would have asked the folks in 1958 when NASA was created what the end result would have been to humanity and how it would have elevated the human condition, I don't know that they could have told you back then there's no way they could have told you how much their technology has advanced. But it is true, at NASA we have over 1,200 patents. When we do work with private companies, in many cases we put it into the contract itself that those private companies get to keep their own intellectual property. They can file their own patents. So there are a lot more patents associated with NASA than just the 1,200 that we own. When NASA does something, we do in fact patent it. And our scientists and engineers that do the patent work, in fact, we're very forward-leaning in the sense that if that patent gets licensed by a private company, the first $5,000 of that license goes to the scientist or engineer that works at NASA for that activity. We're trying to incentivize these kind of inventions and capabilities. And of course, if it ends up being something that gets commercialized, there is a small royalty that gets paid to the inventor as well. So NASA is very forward-leaning on this. We understand the value of patents when it comes to inventions, and we try to make sure that our people are appropriately compensated when they invent something that's magnificent. One thing that I think is important, one of these patents, for example, you guys have cell phones, I presume most everybody in here has a phone with a camera on it. That camera was invented for NASA. We were trying to figure out if we wanted to have an electro-optical sensor that required very little power, that had high resolution, what would it look like? And we invented this little camera that ultimately got licensed back in the 90s, got licensed to Nokia. And now it's, of course, I see people taking pictures of me with it right now. But this is a NASA technology and capability that has now been licensed to the world. And of course, we built it for rovers that are now on Mars. So,
Great, thank you.
Yeah.
And I know we're running kind of tight on time here for panel. The next panels we have coming up, but kind of a follow-up on that.
I'll be quicker. Yeah.
Okay, no problem. What are one or two new policies or laws that may be needed to help keep this pipeline of new technologies going and thriving?
Yeah, I think when we think about space policy, there are a lot of folks who have the nostalgia of Apollo, and it was the United States government purchasing, owning, and operating everything. When we think about the future, we need to make sure that it's not the United States government purchasing, owning, and operating everything. And instead, we need to have a new era where we partner with commercial and private industry that are looking for customers that are not NASA. Why? Because then we can grow faster, and we can drive down cost, and we can increase access. And I'm not just talking about hardware, I'm also talking about data. So the weather enterprise, for example, there are companies out there that are building satellites that can share data with NOAA, the National Oceanic and Atmospheric Administration. And that's something that I think some lawmakers, it makes them nervous. We don't want private companies getting involved in our weather enterprise. And what I hear is that weather is a global public good, and therefore it needs to be provided for free. If you take that to its conclusion and you say that food is a global public good and therefore it needs to be provided for free, then nobody is going to produce the food. And so what we have to do is we have to think outside the box. And if we want to say, how do we get as much technology and capability from space, whether it's for weather or other types of remote sensing or navigation or communication, whatever the case is, we need to look at things differently and say, just because certain people around the world would like to call it a global public good, remember what the end state of that means. That means that the private industry is not going to be investing in it. That means the private industry is not going to be getting customers that are not the government. And when that happens, you don't get the technological explosion that you would get otherwise. So when we think about this, I think what we need to be focusing on as a country is commerce. How do we enable space commerce? And I know we've got folks here from commerce that's keenly what they're interested in. NASA wants to enable that. We want to start the ball rolling, retire the risk, prove the technologies, and then allow commerce to take place and elevate the human condition for everybody.
Administrator, thank you so much.
Thank you. Yeah.
Please join me.
My pleasure.
Thank you to you, and thank you to all the great work NASA does. It truly is an American treasure, and the work you all do is absolutely phenomenal. And I want to extend special thanks to all the folks at NASA who helped us put this program together today.
Absolutely.
Thank you for coming.
Thank you for having me. Thank you, guys. I would like everybody here who's interested in technology and spin-offs, know this. You can go to technology.nasa.gov, and there you can find every NASA patent that you want on technology.nasa.gov. And also on that same website, you will find we have software. We have over 1,000 different software packages that are available to the public. NASA has been really forward-leaning about making everything public. We produce this book every year. It's called Spin-Off. This is the book for 2019. You can see it's pretty robust. We do this year in and year out, and this is just a list of all the spin-offs from 2019. We've been doing this since like 1976. It is mind-boggling if you put all those books together and look at them. This book is available online again, technology.nasa.gov. This book available along with all of the patents that we have as well. So thank you all so much.
Welcome to our first panel this afternoon on administration initiatives on space exploration and space commercialization. And by the way, if you heard the administrator, they're not mutually exclusive categories by any means. They're very, very much related. And I think you'll see that as we talk through the panel today. It's no secret right now that the Trump administration, at a time of renewed emphasis on space, places strong initiative on the energy and the innovation of the private sector. I sometimes like to say that at Commerce, every week we see entrepreneurs come across our doorstep. Some are from large companies, some are for small companies. Some look like they've been in a garage for the last 6 months, but that's okay. We like those ones as well. Those are the ones that are likeliest to come in for a patent. And so we want to talk about those today. Those are also backed by an increasingly robust private venture community and an insurance community that are encouraging diversity, that are encouraging innovation, and that are encouraging new approaches to business. Yesterday, I'm sure the Secretary will probably mention it this afternoon, yesterday we were down at OneWeb where we inaugurated this state-of-the-art satellite manufacturing facility that is really using fundamentally different state-of-the-art business practices in creating a capability that, for example, will produce 15 satellites a week. That is not an easy task, but it is truly state-of-the-art. So everyone, and by the way, Administrator Bridenstine talked about Space Policy Directive 1. All of the space policy directives, we now have 4 of them, speak to commercial space specifically as well as the growth, the rapid growth of the global space economy. And so we'll talk to that. Today I'm joined by four very talented colleagues with experience in space entrepreneurship and innovation and the role of intellectual property in it. We have Jeffrey Mamber, the CEO of NanoRacks, Melanie Strickland, the founder and chief strategy officer of Slingshot Aerospace, Christopher Ingraham, who's the stakeholder communications manager for the ISS National Lab, and Dr. Marilyn Dittmar, the president and CEO of the Coalition for Deep Space Exploration. By virtue of their backgrounds and current experiences, each of my colleagues brings a rich but also very diverse understanding of the factors that encourage or impede innovation, including the role of intellectual property. So what I'd like to do is ask each of the panelists to speak for maybe 3 to 5 minutes with some introductory remarks. I'll introduce you first, and then we'll save time for questions at the end. So Jeffrey, why don't we start with you? Jeffrey has served as the CEO of NanoRacks since 2009, growing the company into the first commercial space station with customers. We like to hear about customers. Today, NanoRacks is, you do as well, I'm sure. Today, NanoRacks is focused on commercial free flyers for research and manufacturing. Before NanoRacks, Jeffrey was the only American to officially work for the Russian space program. You have an extensive set of interactions with the Russians. I hope we'll come back to that in the course of the conversation. Jeffrey also represented Russian space organizations when the initial International Space Station contracts were negotiated. In 2012, he was awarded the NASA Exceptional Public Achievement Medal, and 2017, the Space Frontier Foundation's Pioneer of New Space Award, and just recently, the National Space Society's Space Pioneer Award. And in addition, you spoke and testified before the National Space Council, I believe at the exact same session that I did back in 2018.
Yes.
And so why don't we turn it over to you?
Great, thank you. Pleasure to be here. This is sort of for everybody who likes to think of themselves as creative and has a company that likes to think of itself as creative. This is sort of the mother lode to be here, and we all appreciate what you do and everything you do to move us forward, both as a company, individuals, and a nation. NanoRacks has been in the startup mode, I guess, for 9 years now. We were the first company in the world to own and operate our own hardware on the space station. And if you're not from our industry, you cannot understand what a significant moment that was. For 50, 60 years, everything in space, everything especially associated with human space flight in low Earth orbit, was owned and operated by NASA. And then the administrator made reference to the growing commercialization, where in 15 years ago, NASA said, wait a second, for cargo, why don't we let the private sector design the launch vehicles? This was post-shuttle program. And we approached NASA in 2009 and said, we don't want your money, which got their attention. And we said, look, we want to design, develop, and operate and self-fund our own hardware to do in-space services. And NASA at the time took a chance on us and said, okay, we'll let you do that. And so we've grown since then. We're now, we have customers in over 30 countries. We've deployed over 200 small satellites called CubeSats from our own deployers. We've had multiple biopharmaceutical companies. We've had education, all with no overt NASA funding. And when I say overt, I mean that, of course, we can only exist based on the taxpayer investment in the International Space Station. But where we get funding from NASA is as a customer. And we have to produce the services. And if we don't produce the services, it's like any commercial venture. And our customers include NASA. They include ISS, formerly CASIS. They include the German Space Agency, the UK Space Agency, but they also include companies around the world, such as Planet Labs, Spire, biopharmaceutical companies. So we're really proving that there is indeed a market in low Earth orbit and that there are price points. Getting to the point of this event, I'll start on the negative. Our first product is called a Nano Lab, and it was to standardize and miniaturize laboratories on the station. And I made the conscious decision in 2009 not to patent it. I wanted it to be an open source. I wanted to have competition. Be careful what you ask for. But because we were first, I did not think we could be the sole pathway going forward. So on the Nano Lab, I made the decision. Now there's several companies domestically, a company called Space Tango in Europe, one with the great name of IceCube, and it's based on our technology and our design. And I'm hopeful that will raise the market up. Since then, we have one patent. We have several in the pipeline. If I can talk to any examiners are here, just forget. Anyway, we have several in the. We're doing an airlock on the station, which is the largest commercial module. It's self-funded. We have a number of pending patents associated with that. A couple of quick comments. I'm sure we'll get to back and forth. But in my area of the world, it's extremely complex. Under our agreements, we can launch with the American launch vehicles, we can launch with the Japanese, we can launch even with the Russians. We didn't think there was a difference. Well, it turns out there is in terms of patents. Turns out that if we launch something on a Japanese launch vehicle, it might impact our ability to get a U.S. patent. It's extremely complex. Everybody, such as the administrator and myself, I was there in the early days when we created the ISS structure. We love the international aspects. It's not good for patents, okay? It's incredibly complex, and we're trying to figure that out. Not only being in space, on the space station, but having all these international partners. What happens if a Russian cosmonaut touches the technology? What does that do to our patents and how we have to apply? So I'll leave it there.
Thanks, Jeffrey.
Sure.
Next, we'll turn to Melanie Strickland. Melanie is a co-founder and chief strategy officer at Slingshot Aerospace, a tech startup revolutionizing the way commercial companies, first responders, and governments use Earth and space observation data to close the gap between data analysis and critical decision making. During her 21-year career in the Air Force, she logged over 1,500 flight hours aboard a ground surveillance aircraft and led the development and deployment of experimental spacecraft and space situational awareness technologies. Melanie is passionate about advancing space awareness. She is a champion for STEM initiatives and enjoys inspiring youth to pursue their dreams. A topic we talk about at Commerce a lot, the talent that is going to fuel the trillion-dollar space economy. Melanie?
Thank you, and thanks for the invite to be here. It's quite an honor. Slingshot was born from some of the frustrations that I and one of my co-founders had first-hand experience in the Air Force. So like he mentioned, I flew on a surveillance aircraft for a very long time. This was back in the early 90s, before the aircraft was actually deemed IOC. So there was a lot of experimentation and tactics and procedures that were being developed on the fly. But still, we were bringing in synthetic aperture radar, about 250 square kilometers every second, essentially. And the only real-time information that we could extract from that very rich data set was moving target indicators just based off of a Doppler shift. So we could see where cars or convoys were, where they were going. But we would pull the disk off the jet every afternoon or every morning when we came off of those long missions and send them off to an intelligence agency that would then take 3 weeks or 3 months to extract information that could have saved the day or produced a different outcome of a war or conflict, et cetera. That was frustrating to me. I later moved into the space side of the Air Force, which was a dream from the time I was a little kid. So really, my Air Force career was the combination of my two loves, air and space. And so on the space side, I was fortunate enough to get to work on developing some of the technologies that are on orbit doing both Earth observation and space situational awareness. But the same problem, it's pervasive. We build and we put a lot of emphasis into widgets or systems on orbit or systems on aircraft. But we sometimes, and it's getting better, but sometimes data analytics is an afterthought. And it's very important that those folks that are either on the front lines or responding to disasters or insurance agencies that are trying to get people to their lives faster have the information that they need very, very quickly. And so that's why we started Slingshot Aerospace. But we knew there are two of us that are Air Force officers. We knew we couldn't do it by ourselves. And so we partnered with our CEO, David Godwin, who's a renowned data expert and has built 4 companies doing very high transactional extraction of insights from large data. So that's how we were born. We started July 15th which was 15 days after I retired from the Air Force. And fortunately, we were selected for TechStars. So if you don't know about TechStars, it's a mentor-based accelerator. And we're so fortunate that that accelerator program, we believe, accelerated us about 2 years. And so now we've got contracts with the U.S. Air Force, taking these capabilities back to those pain points that started Slingshot, and also commercial companies like insurance, travelers, USAA, et cetera. We have several provisional patents in work right now. It's always a balance for a startup company to understand, do we put a large investment into patents early on in order to get the venture capitalist backing and to protect our IP going forward, or do we put that into tech maturation? And so fortunately, we've got great mentors and we're able to balance that. That's where we are today.
Thanks, Melanie. Next, we have Christopher Ingraham. Christopher is the Stakeholder Communications Manager for the ISS National Lab. In that capacity, he's responsible for building and maintaining the lab's relationships with both government industry stakeholders. Before joining the ISS National Lab, he spent 8 years on Capitol Hill, most recently for the House Space Subcommittee, and then before that, 4 years as the Space Policy Advisor to then Congressman Jim Bridenstine. So you had heard many of those things before, right?
A few times.
Okay. Christopher.
Thanks, Kevin. It's great to be here. Thank you to the Patent and Trademark Office for putting this on. This is an awesome event. So I'm with ISS National Lab. We were selected in 2011 to be a systems integrator for space. That means connecting research and development users with all of the different aspects of things they need in order to do R&D on the space station. And sometimes that includes connecting them with the facilities and the services that Jeff's company provides. We are responsible for managing 50% of the U.S. portion of the ISS, and that means the crew time, the up mast to station, down mast communications. We're responsible for doing that in order to specifically enable R&D to be done by the rest of the government besides NASA, academic and nonprofit institutions, and the private sector. So that's where we differ. We're separate from NASA. We're a nonprofit, non-governmental organization, separate from NASA, and going off what my former boss said a little earlier, he so eloquently put all of the benefits that we've received from space exploration, but a lot of those come downstream from NASA's exploration and science mission, whereas we are specifically tasked with enabling R&D that benefits life on Earth, directly benefits life on Earth, and that's what we're responsible for doing and for sending up there. We have been around, like I said, since around 2011, 2012. We've sent nearly 400 projects to the station, and we found some areas, some disciplines, some science disciplines that have shown a lot of promise, particularly in the areas of industrial biomedicine and advanced materials manufacturing. And so going forward, we really want to start building programs around those areas like that and a few others where we can do iterative science, have a strategic roadmaps, and lead to tangible endpoints so that we can bring those benefits back to the American people and to the world and improve the human condition. So we're trying to build programs around this, and that involves going out and recruiting partners in this, whether they be other agencies or academic institutions or private companies. And a lot of times when we go out to recruit these folks to put significant investment into the R&D, particularly when we talk to private companies, one of the first questions they ask is, okay, so how does my intellectual property that I might develop in the course of this process, how does that get handled? And our answer, unfortunately, a lot of times has stopped a lot of conversations before they can really get started. Because at the end of the day, the work is being done on the International Space Station, which is a government vehicle, a taxpayer-funded vehicle. And as much as the administrator said, NASA really does lean forward to the extent that they can in terms of waiving rights and making sure that they're not keeping them to the extent that they are able to waive them. They can't waive march-in rights. They can't fully say that will never happen. So the fact that we can't say you fully 100% control your intellectual property gives people cold feet, especially when we're talking about the types of the level of investment needed to really bring science from the basic area, which we've been playing in for the most part of our history, and moving it more into the applied R&D area. So if we really want to drive innovation and build off of the country's history and the world's history of space exploration through the International Space Station, one of the biggest things we're going to have to figure out as a country is how we grant potential users, potential R&D users of the ISS, full control over their intellectual property.
Thank you. Our final panelist today is Dr. Mary Lynn Dittmar. She is currently the president and CEO of the Coalition for Deep Space Exploration, which is an over 70 company strong industry trade group supporting NASA's programs of record and industry involved in human space exploration, space science, and space commerce. She's a member of the user advisory group of the National Space Council and serves on the Commercial Space Transportation Advisory Committee, advising the FAA on matters related to commercial space. She also serves on the Space Studies Board of the National Academies of Engineering, Sciences, and Medicine. She gets extra credit today for an extra special effort in trying to get here. Mary Lynn, please.
Yeah, the effort was, as Kevin knows, I've been on crutches for the last 3 years, and actually I'm in the process of getting off them, in part due to some NASA technology, which I have to add. And today at 1:29, the fire alarms went off in the building and shut down the elevators, and I'm on the 5th floor, and I'm only about a month off the crutches, and let's just say it took 20 minutes to get down the stairs. So I'm texting Kevin madly, I'm coming. I need the transporter is what I really need. I mean, somebody needs to come along and sort of, all due deference to Gene Roddenberry. What I wanted to do was sort of talk a little bit about some history, since this was originally kicked off as part of the Apollo 50 anniversary. And I'm not going to go through all of this because there literally have been dissertations written on this, but how many of you know the history of the integrated circuit? A few of you. Ooh, this is one of those stories maybe should be retold and retold and retold. So I'll try and do the very short version of it, but it goes directly to patent law. And the history of the integrated circuit is that actually in 1952, there was a speech given by a British radio engineer named Geoffrey Drummer who postulated an integrated circuit. He didn't patent it, he didn't claim the idea, but the following year, a guy named Robert Harwick did. He basically came up with an idea of trying to shrink down transistors, resistors, capacitors, all kinds of things, and get them onto a single strip of metal. And what he did was actually patented that idea. And that idea was then picked up by a guy named Jack Kilby. And Kilby actually got the Nobel Prize for the invention of the integrated circuit, and for a long time was getting the credit as sort of the inventor of the integrated circuit. But now what's happened is that people have looked at that, and this is one of those ideas like Jeff's idea, okay, which came about, and then a whole lot of other people grabbed it and built on it. So the history of it is fascinating. Kilby patented the idea of the integrated circuit and actually developed the first one after he moved from the Army to Texas Instruments. And Texas Instruments actually was the patent holder. But meanwhile, there was a little company called Fairchild Semiconductor, which some people may have heard of, okay, and a guy there named Robert Noyce. And Noyce was really, really fascinated by the idea of the IC, but thought that there were some limitations to the design. So he, in turn, borrowed an idea from a guy named Jean-Henri, who had thought about some ways to basically get all this stuff laid out in parallel. And another guy, okay, whose name I'm blocking, that'll come back to me in a minute, okay, who had come up with a way to avoid interference, okay, among all of these little circuits. And he took all of that, okay, and managed to get everything onto a single chip about 6 months after TI had filed for their patent. And then I'm going to roll forward really quickly. Okay, at the same time, there's a thing called the Apollo program happening. And NASA needed some capability to manage guidance, navigation, and control. They needed it on their onboard computer. And the whole idea of having all this stuff on a chip, okay, not the ones we think of today, but still one, okay, one chip was very appealing. So they started talking with MIT Draper. And Draper Lab was in the process of trying to work on all of this. When TI got theirs out, that got Draper's attention. But then when Fairchild came out with theirs, they managed to get it onto a chip and then managed to get it onto a silicon chip. And at that point, what ended up happening was that MIT Draper said, okay, we'll take 5,000 of those. And they were over $1,000 a piece, okay? So do the math, all right? That's how NASA originally invested, all right, in the integrated circuit. And MIT started working with those chips at that point, okay? The Army was also really interested, as was the Air Force, because there was a thing called the Minuteman missile program that was happening. All this was going on at the same time, okay? So they're really interested in onboard capability, and so they started ordering these chips to see if they're going to be able to play with them. But NASA had 30% of the world's supply at that point through MIT Draper, okay, just trying to do this work. So fast forward again. It ends up, okay, in the Apollo onboard system, which, as we know, went pretty well, okay? Fairchild, at that point, it moves forward and gets a semiconductor IC done, takes it to market, and at that point, the patent war started. It was 1966. Texas Instrument filed all manner of lawsuits, okay, against all kinds of people because they held the original patent. And that patent war went on for 6 years, okay, during which there was tons of blood, okay, in the streets, and a lot of technology development actually held back because people were concerned about continuing to push the technology until they had the IP situation straightened out. It finally was straightened out in 66. The Air Force and the Army grabbed it for the Minuteman. By 1968, which was a year before the Apollo landing, the cost had dropped from $1,000 a chip to $2.33 a chip, because between Apollo, the migration into satellites, and the Minuteman missile, okay, the production demand was so high, okay, that it drove production through the roof, okay, and therefore dropped the cost, okay, okay. What eventually ended up happening was that Noyce got unhappy at Fairchild, along with a guy named Moore, who you may have heard of. And they picked up, left, moved out to a little patch of land in California, okay, and decided that they were going to try to drop the cost of these things even further and commercialize them even more broadly. And they got $2.5 million worth of investment from a guy named Art Rock, who raised the money in 2 days. All right, 2 days. And they decided, because their names were already taken by a hotel chain, which I think is really funny. Okay, this is how this happened. They were going to call their company Integrated Electronics, or Intel. And Silicon Valley was born. I'm just a little bit of exaggeration there. Anyway, sort of move forward to 1974, okay, and then what you get is you get these things onto circuit boards, and from there it's a straight leap to, what did I do with my phone? I left it in my backpack. Okay, it's a straight leap to this. So, okay, the history of the integrated circuit goes from, okay, labs, actually an idea in 1952, okay, through TI, through the Army, through Apollo, through the Air Force, okay, eventually into Silicon Valley and this thing that you guys hold in your pocket. So what often happens is that people talk about the Apollo program as having, it didn't invent it, right? It leveraged it. But it certainly popularized it. I mean, the word got around through the entire engineering technology community, okay, that this is how this was happening, how the onboard guidance, navigation, control was handled. And so there's often a conversation about how Apollo played a key role, and it did. But I just want to point something out, and I think probably all of the panelists here will be able to respond to this. Without IP, which made this it made it messy. I mean, you know, it was messy. But without IP, it's absolutely central to the story. Without IP, there would have been no Texas Instruments, because everything that happened afterwards, okay, was based on this. There would have been no Fairfield. There would have been no Intel. There would have been no Silicon Valley as we understand it, no Apple, no IBM in its modern form, no Honeywell, and I would argue actually probably no modern NASA. I mean, not certainly in its modern form. And today, NASA's civil space programs are providing this indispensable backbone for continued development of technology that has applications certainly in space, but also has application in Earth. And all the panelists have sort of talked about it. The Orion program, which is the next generation crew vehicle, there have been over 60 technologies and processes that have been transferred directly from the Orion program to the commercial crew program. So they're developed under public availability, right? And then they're transferred to those. And that's just manufacturing stuff that's happening on the SLS, as painful as some of that's been, okay, has been hammered out on the SLS, all right, and is actually now being transferred to the manufacturing, has applications in the manufacturing sector. This is certainly true in space science, where instrumentation demands, okay, drive really, really fine technology, okay, that has taken us not only to the reaches of the outer solar system, but it's brought us closer to our own star than we ever imagined, okay, at the beginning when the IC was originally developed. So I just want to sort of point to all this and say, what can history teach us? One of the things it can teach us is if we have this happy set of circumstances, which, by the way, aren't going to happen every day, okay, where you have a technology that's being developed, you have a need for that technology, you have a pathway through IP, okay, to commercial and control of IP, data rights and patents, okay, to basically control that technology and then commercialize that technology, okay, and you have an investor or investors who are able to bring private investment who can see the potential, okay, and bring that to the table, and then help you build from there, okay. If all of those things can come together as they did with the integrated circuit, right, that's how we have broad-based technologies that can come to the market. And one thought I just sort of like to leave you forward thinking forward about. Space exploration, space science, space commerce, okay, these operate in a highly constrained environment. There are limitations everywhere. Space will kill you 15 ways, it'll kill your machinery 15 ways, okay, there are a lot of, it's very exacting engineering. What we know about human beings is that when they're faced with constraints, but they have a drive, they innovate. So one of the things that's really interesting when you think about space exploration is there are certain needs that are involved in space exploration, science, and commerce that we have here. We need clean water. We need power. We need power acquisition, storage, distribution. We need clean energy. Okay, we need all of those things for space applications, and we need them here. So can we use what's going on in space as a driver to basically break through technologies that are used in space as well as used here? Wouldn't that be awesome? It's already happened. Okay, we're looking for the future and hoping that it further. Doors open. Doors open.
Thanks, Mary Lynn, very much. So let's turn to a couple of questions. So we think the vision is clear. You know, we heard Administrator Bridenstine. The vision is pretty clear. The administration has put in place a number of space policy directives that are actually designed to deregulate, to encourage, et cetera, et cetera, et cetera. What are some of the other mechanics that need to be used in the government-industry relationship to achieve the vision that we achieved in Apollo, that we've achieved in the example that you've set, that we can reach the vision that we're all moving toward, as reflected in Administrator Bridenstine's comments? What are some of the internal mechanics? He talked about licensing, for example, as one method. Are there others?
I think Mary Lynn touched on it. Unfortunately, Christopher and I have organizations that are on the International Space Station, which can be quite difficult. But there's a phrase at NASA now they use all the time. They say one customer of many. And what Mary Lynn just described is for us at NanoRacks the solution. We want NASA and other space agencies to behave as customers, yes, one of many. So that's the goal we strive for. It's licensing is one thing, a customer in a commercial sense is another. We're not quite there, but we're getting there.
Okay. Anyone else?
I think there's something to be said for having kind of a holistic, government-wide view of how we want to go about handling kind of the space economy or doing work in space. NASA has, kind of taken the lead on a lot of this. They just released a LEO development policy last month, which is good first steps. I know your office is doing a lot of work here, and there was some talk about the Space Council driving towards kind of a national microgravity strategy. Right. And I think getting something like that in place would be very beneficial to kind of serve as a guide rail for how we're going to treat the next phase as we transition from the government owned and operated to one customer of many, multiple government agencies using space, a vibrant ecosystem and economy.
So in the office, we often hear about the role of the government as customer and making sure that the government doesn't sit back and wait and see till something becomes commercial. It's too late to get in at that point. The other thing we often see is a need to really look deep into the market at the kinds of capabilities that entrepreneurs are bringing forward, because the time that they come forward for a license, it's way too late to start thinking about those capabilities either as a customer or from a regulatory perspective. And so improving how we actually look into the market, do some sort of understanding of what kind of capabilities people will bring forward, whether they succeed or not. They won't all succeed, obviously. But how do we actually look deep into the market for that? Melanie, please.
I think, one thing is evident across DoD, across the government. There are innovation cells popping up everywhere, whether it's Air Force AFWorks or DIU or these initiatives that are there to, at least gain insight into what startups are doing, what innovation cells are out there, even what larger companies are doing and how they're partnering with small companies. But something that's missing, even with other transaction authorities that NASA's used for a long time, DoD is now starting to use these. But even with that, as we start to develop space policies, I think side by side with that, not just technology innovation units, but regulation innovation units. Understanding, can we put cohorts together to help small companies through the contracting process, or even better, can we start to revolutionize our regulations in this country to allow for, those innovations to become productized faster for government use and for commercial use. A lot of these technologies are, we're leading the market. We were talking about this earlier. Some of these technologies, like with us, our artificial intelligence, to say denoise signal from remote sensing satellites. So if we want to take that to market, yes, we can go to InsurTech and we can go to disaster response, and we can explain how they can get critical insights much faster and easier than in the past. But if we can't get the investment dollars early on, either from government contracts, which, oh, by the way, usually come with, they need unlimited rights to the data rights, right? And so that is a limiting factor. But we need government investment, we need VC investment, and so there's just got to be a fine balance between, the cohorts that are out there driving innovation and those cohorts that hopefully will come about to drive innovation on the regulatory side.
Yeah, the regulatory challenge is real because the speed of the technology and the business models, we shouldn't put those aside, is really moving at lightning speed. We used to say in space that something would come along in 10 years. Today it might be 10 weeks if we're not careful. And so keeping up as regulators, not only at home, but in an international context where lots of folks are focused on regulatory issues, very, very important. I see we only have a couple of minutes left. Maybe we could take a question from the audience? No, we won't take a question from the audience. Marilyn, did you want to say something there at the end? Please.
I just want to follow on sort of points. The FAR takes a beating. I've often been the one beating. So I just want to say something about it. There really is a tremendous amount of flexibility in that instrument, as well as other transactional authorities for doing acquisition. What we don't have, though, is a workforce that's trained to fully utilize it. What happens is that stovepipes within institutions, all manner of institutions, and I'm not pointing at any particular agency, all manners of institutions have their own culture, and those cultures actually affect the way that people think about doing acquisition. We need, in my view, a whole-scale retraining of procurement and acquisition in this country. We may also need a complete overhaul of the FAR. I'm not sure which would be more difficult, but basically in each one of those cases, I think we need to seriously look at this, because it really is, when we have such a huge bottleneck in acquisition that we're preventing technologies that are actually critical to national security from being developed, okay, we have a problem.
As always, time passes quickly, and so we're out of time. Would you join me in thanking the panel for a great discussion?